So we're going to get started here with maps and give you an introduction to maps. Uh, so let's just dive right in. First off, every map is a lie. Every map has some kind of mistake on it. It's absolutely impossible to draw a flat map of a spherical Earth accurately because when you try to take that Earth and flatten it out, you end up having to distort something. Lewis Carroll, who wrote Alice in Wonderland and Through the Looking Glass, once joked that the only way to have a accurate map is to have one that is the exact same size as the object you're trying to map. And so in this short story, he talked about this town that had a map that was the size of the town and literally covered the town, and everything was in a 1-to-1 ratio. And that's fine and all, but of course, it's impractical. And so different types of maps use different projections. You take a sphere and we wrap some shape around it. The most common one for your common projections is a cylinder. So you wrap a cylinder around that sphere, and then literally every point on the sphere gets projected out. So the equator, where it's touching the sphere here, as long as I'm putting north up, then is going to be accurate. But as you get to the polar regions, what's on the surface of the sphere gets stretched out as it gets to the cylinder there and is going to be distorted. There are other projections, and so then those other projections end up having different distortions. And it's not that any projection is right or wrong. Different projections show different things, and they will always pick some part to be accurate. And there's a trade-off there, and it is a trade-off that is chosen. But there's always some kind of difference between length, the area or size of an object, the shape of an object, which isn't on my list here, or the direction to that object. And your largest distortions are at the edges. The most common map projection that you've seen in your life is the Mercator projection. It horribly distorts area size, though it does a decent job with shape and direction. Your links are also distorted. The closer to the poles you get, the distances, your scale is different than it is at the equator. Anyway, the upside of the Mercator projection is it was very useful for navigation. If you measured an angle on the map, it perfectly matched the angle in the real world, and so you could navigate that way. It did not send you, though, through the shortest path. It actually was a slightly longer path because the Earth is curved and you're mapping out straight lines here. The shortest distance between any path is a straight line, of course, because you'd have to dig through a spherical Earth. That isn't ideal. And so then you end up going around the edge of the curve instead. That's still the shortest distance, but the Mercator projection doesn't do that. However, it's led many people to think that Greenland and Alaska are gigantic and that the United States is bigger than Africa. Heck, Greenland is bigger than Africa, and that's just flat out not true. The Gall-Peters projection, which is another one you've probably seen before, does a much better job with area or size, but really distorts shape. So there's always different trade-offs. And different projections can use different measuring systems to mark locations. And so then different measuring systems are used, and we're going to introduce some of those here. Of course, the first one here is one that you're familiar with, and that is latitude and longitude. I actually need to grab my globe here. But latitude lines are horizontal lines that end up dividing north from south. However, because they go horizontal, they divide the opposite direction. This is what causes a lot of confusion. They go from the 0-degree mark, which is set at the equator. It makes sense to set a mark there because we're exactly halfway between the poles there along perpendicular to the axis of rotation. So we define this as 0 degrees, and then we go north or south. Because latitude lines wrap all the way around the Earth, then we only have to go up to 90 or down to a 90. And so we label them as 90 north or south, or 90 positive and negative. And of course, our central point there is the equator, which divides the northern and southern hemispheres. There we have a definite defined point. For our longitude, they are vertical lines that divide east from west, and they go through an arbitrary spot that humans have picked called the prime meridian here. I believe it's that one. I might be off by one mark there, but there we go. The prime meridian, vertical line that goes divides east from west. Because there's not a definite stopping point, though, because if you go to the North Pole, once you're at the North Pole, any direction you go is south, at least momentarily, and realistically for a decent distance before you can really pick up east-west. We're also ignoring the fact that magnetic north doesn't match geographic north, but more on that if you take other classes. Anyway, actually, we may get to it later this year. Anyway, with east-west, though, you can start traveling east and go east forever, or west and go west forever. And so there is no fixed point. That was totally made up, but that is called the prime meridian, and we end up counting all the way up to 180. So with latitude, we only cover 180 degrees of arc, but with longitude, we cover a whole 360 from 180 east or west, or negative 180 to positive 180. This also means we end up having to have the international date line exactly opposite of that at 180 degrees. It fortunately goes through the Pacific and doesn't bisect any islands, so that's kind of nice as well, though that's kind of a coincidence based off of where we picked the prime meridian to be. I've got a story for that about that here for you in just a moment, but I want to get to a different slide for that. But the prime meridian is totally arbitrary because there is no definite we should divide it here for that one. I will also point out that with the positives here, that this is very Western or European centric. There is no reason to call north up or north positive and east west positive, but it ends up being a very European centric thing here because north is positive and east is positive. Here in the United States, where we are, north is positive, but we, for our longitude, are actually negative. And we'll get to an example of where we're at with latitude, longitude here in a bit. To get into why this prime meridian was arbitrarily picked, we also have to mention time zones. That time zones are 24 global divisions that are parallel to longitude lines and try to align the Earth's time with the sun, to have sunrise be a certain time, to have midnight be roughly in the middle of the night, to have the sun's highest point in the sky be roughly noon. Although I will point out that where we're at, the sun will never be directly overhead, and it will never be at its highest point at noon here where we are. Because of the tilt of the Earth, we're about 40 degrees north, and that's higher than the Tropic of Cancer and Capricorn. I might have those two flipped, but they're at 23.5 degrees, and because the Earth is tilted at 23.5 degrees, those are the last places. Everything in between there can at some point have the sun be directly overhead. North or south of those tropics, it's just not going to happen. Anyway, it turns out that because there are 360 degrees in a circle and 24 hours in a day, each time zone is roughly 15 degrees wide. You'll notice that's not exactly true because countries have time zones match natural borders. Or man-made borders. When Russia was part of the USSR before the fall of the Soviet Union, they actually had all of Russia beyond Moscow time. And so they span, I think it's almost 12 time zones, if not exactly 12 time zones, and they chose to have it all on Moscow time. And so you could have midnight during daylight in the far reaches of Russia and vice versa is absolutely crazy, but it's their choice. There's also some interesting places like some of the Canadian islands here. I believe it's Newfoundland and or Labrador. They actually offset their clocks by 15 minutes. And so whereas everyone else, we should roll around on, change the hour on exactly the same time. What hour we are is different. But everyone else, everyone changes the hour at the same time, except for some locations that divide on the half hour, or these islands which divide on the 15 minutes. So when we roll over to an hour, there are some places that roll over only to a half hour to a 15. Really causes problems with trying to establish time for communications, especially over the internet and banking systems and GPS systems. It's complicated, but that's not our topic or our focus here. I will also point out that we are -5 from the main time zone, what used to be called Greenwich Mean Time, which now is called Universal Coordinated Time.